You know that feeling, right? You get a brand new smart device, you're excited to get it working, and then you spend the next hour just pulling your hair out trying to get the thing connected. We've all been there, and it feels like it should be so simple, but it almost never is. That frustration, though, it points to a much bigger question.
I mean, seriously, think about it. We connect our laptops or our phones to Wi-Fi all the time. You find the network, you punch in the password, and boom, you're online. So why is the Internet of Things, or IoT, such a different story? Well, the answer really comes down to a fundamental misunderstanding of what an IoT device actually is. You see, we all kind of assume it's just a simple plug-and-play gadget, a piece of hardware. But the reality? That IoT device is just one single piece of a much, much larger puzzle. We're talking about a whole system architecture. It's not about just plugging one thing in. It's about making all these different complex parts talk to each other and work together perfectly.
So to really get this, we've got to peel back the layers of that architecture. So let's do it. Let's break down the 5 most common reasons why that shiny new sensor you just bought absolutely refuses to talk to your platform.
Okay, first up, the #1 reason connections fail is also one of the most basic. It really all comes down to language.
It's called a protocol mismatch. And honestly, the best way to think about a protocol is that it's just a language. So imagine your device is speaking Spanish, but your cloud platform only understands Japanese. It doesn't matter how well they're working, they are never, ever going to communicate.
And we're not just talking about 2 or 3 languages here. Oh no, it's a whole world of them. You've got your standard web stuff like HTTP, you've got these super lightweight standards like MQTT that are perfect for IoT, and you even have these old-school industrial workhorses like Modbus. If your platform doesn't speak the device's specific dialect, the connection is just dead on arrival.
Okay, so let's say they are speaking the same language. You got that part right. Well, you're not out of the woods yet. And that brings us to our second huge hurdle.
Data format differences. So stick with the language analogy. This is like 2 people who both speak English, but one of them is using modern, everyday slang, and the other is speaking in perfect Shakespearean English. They're technically using the same language, but the sentence structure, the way they organize their words, is so different that they just can't understand each other. It's gibberish.
In the world of IoT, this little package of information is called the payload. And if that payload shows up neatly organized in a format the platform expects, like JSON, everything's great. But what if the device sends a raw stream of hexadecimal code? The platform has no idea how to parse that, so rejected. It's all just data, but without a shared structure, it's basically just noise.
All right, let's move on to hurdle number 3. And this one is critical because it happens before a single piece of data even gets sent.
We're talking about incompatible security models. Think of this like the bouncer at a nightclub. Before you're even allowed in the door, you have to prove who you are. So if your device shows up with one type of ID, but the platform's bouncer is looking for a totally different one, nope, the door stays shut. The connection is refused right there at the digital handshake.
And you guessed it, just like with protocols, there's no single standard for security either. Some systems just use a simple token. Others demand these really complex digital certificates and something called mutual authentication. Any mismatch in what's expected, and you've got an instant failure.
So let's recap. The protocol matches, the data format is perfect, and security gave you the thumbs up. You'd think you're golden, right? Well, not so fast. Your data can still get lost on its journey. And here is reason number 4.
Connectivity constraints. See, data doesn't just magically teleport from your sensor to the cloud. It has to travel through a network. And sometimes that network is its own separate system with its own rules. Without a proper bridge, your data can make it to the network server, but then it just gets stuck. There's no path forward to your actual application.
This is a really big deal for these long-range, low-power technologies like LoRaWAN or NB-IoT. These networks are highly specialized, and they require very specific integrations to hand off the data to its final destination.
And now for our final and maybe the most frustrating reason of all. And that's because this one isn't even a technical problem. It's a business decision. Some companies build what we call a walled garden. They actually design the firmware on their devices to only push data to their own servers, period. There's no option to change the endpoint. They have intentionally locked you into their ecosystem.
And this right here just illustrates the whole issue perfectly. If we keep thinking of these things as simple gadgets, as just hardware, we are always going to be frustrated. The problem isn't the device. The problem is our approach. So, How do we fix this? What's the solution? It's a fundamental shift in our mindset. We have to stop thinking about the device first. We have to start thinking about the entire end-to-end architecture before we even think about buying the hardware.
And this kind of architectural thinking really leads to 4 key principles. 1. Go with open standards. Pick devices that support flexible protocols like MQTT or HTTP. 2. Check the settings. Make sure the device firmware actually lets you change where it sends its data. 3. Standardize your data model. From day one, define a consistent data structure for your whole project. And 4. Don't be afraid to use a gateway when you need one, to act as a translator for older or more complicated systems.
Okay, so that's the high-level strategy. Now let's get tactical. Here are 5 practical, real-world paths you can take to connect a device to a platform. We're going to use the Favoriot platform here, just as a concrete example to make sense of all this.
This table really lays out your architectural options. For a nice, standard device, you can probably just use native MQTT. If you've got a simpler device, an HTTP API is a great, easy choice. For those tough legacy industrial systems, an edge gateway can be your on-site translator. For LoRaWAN devices, you're going to integrate with a network server. And what about those lockdown vendor devices? Well, that's where middleware comes in. It's a piece of software that acts as a bridge, pulling data from their cloud so you can send it over to yours. See? Every problem has a specific architectural solution.
And all of this brings us to the single most important thing to take away from this entire explainer, the IoT first principle. Before you spend a single dime on a device, you have to design the data flow, the protocols, the security, the whole system. You design the architecture first. So I'll just leave you with this one question to think about for your own projects. Are you just buying hardware and hoping for the best? Is your project built on a device, or are you building a robust, thoughtful system, an architecture? Because honestly, that is the difference between failure and success in IoT.